All right, kids. So this is part two. And we're talking about the derivative of the natural log function. So the derivative of the natural log function is given in theorem 5.3. And what I really want you to see here is based on our u substitution, because a lot of times we're going to have something inside the natural log, something like natural log of x squared or natural log of cosine x or something in there. It's very rare. You're just going to have a simple natural log of x. So what you need to recognize is that we're doing the chain rule. And when we do the chain rule, it turns out that the derivative of the natural log of x is equal to, or the natural log of u oh my gosh, kids, is u prime over u. Okay. U has to be greater than 0, so it can actually be part of the domain of natural log. So this is really what we're going for. We want u prime over u, and we're going to take a look at some of those. For our first one, we could see the natural log of 2x. Here's our u. U is 2x. U prime is just 2. So we have 2 over 2x. Those 2's cancel, 1 over x. For the next one, here is my u. So if we're going to do u prime over u, I have 2x, the derivative of the inside part, over just the inside part. That's the derivative. Of course, all that's animated for you. For the next one, we have a product rule. So this is a product, and we're going to treat it like a product rule. So remember the product rule, u times v, if we're doing the derivative, is 1 prime 2 plus 2 prime 1. So when we look at that in actuality here, I leave the x alone, and then prime 2, this is just going to be 1 over x. 1 prime 2 plus 2 natural log of x prime 1 times 1. Well, that's going to, these cancel here, so I get 1 plus natural log of x, and I'm done. All that animated for you. All right, so we see some kind of chain rule. We have another chain rule. This is like easy, medium, because they don't cancel, medium, hard. And then we get to like, this is a bigger chain rule because the natural log is the inside part, right? So my u is natural log of x. Du is 1 over x times dx, right? So when we're doing this, I'm going to do the outside part. Derivative of the outside part is 3 something squared. The something inside stays the same, natural log of x. And then I'm going to take the derivative of the inside part, that's just 1 over x. Now, I don't care how you write this. We can leave it like this. We can go 3 natural log of x quantity squared over x, whatever makes you happy. But understanding that we have this outside derivative, 3 something squared, and then the inside derivative. Okay. So this is the hard one. And this is going to be sometimes a matter of choice. It's a preference thing. We're going to learn logarithmic differentiation. So let's say we have some function that just looks really gross. If you're just going to take the derivative, if I'm going to find the derivative of this, I'm going to do low d high less high d low. And when I do the derivative of the denominator or the numerator, I'm going to have to do a chain rule anyway. So it's going to get really big, really gross, and it's a lot of work. Okay. So what we do instead is we look at this and we say, okay, well, since y, everywhere that y is greater than 0. You can look at the graph if you're not sure, but this is squared and we're taking square roots, so they can't be negative. And so everything's going to be bigger than 0. I can go and I could take the natural log of both sides. So if I do that, all right, let's say natural log of y. And then I have the natural log of this whole thing, x minus 2 squared divided by the square root. I'm going to actually just write that as a half power, but it's the same thing, right? X squared plus 1 to the 1/2. Okay, so we did the natural log of both sides. Algebraically, whatever we do to one side, we can do to the other. On the right side, there's some cleaning up I can do using those log rules. I'm going to split this into bigger pieces because it's easier to take the derivative of each individual piece rather than do the quotient rule and all of that, right? So I'm going to say, okay, the left side stays natural log of y. The right side is the natural log of x minus 2 squared. It's supposed to be squared, minus the natural log of x squared plus 1 to the 1/2. Okay, so hopefully you're good with that. We just use the quotient difference rule. I'm going to use my exponents and bring those down as coefficients here. So I have the natural log of y equals 2 times the natural log of x minus 2 minus 1/2 times the natural log of x squared plus 1. Now at this point, we still haven't taken the derivative of anything. And I'm going to now because I've split this up and I don't have a chain rule to do like I did before. I don't have a quotient rule at all. So this is pretty cool. These are easier things to take the derivative of. So I'm going to go back and I'm going to say, all right, let's take the derivative of both sides of all of this. And when I do that, the derivative of natural log of y, because this is like u, would be y prime over y. The derivative here, the 2 just comes out. I'm going to save that. And then I'm taking the derivative. So this is, the derivative of this is 1 over x minus 2, right? U prime over u minus 1/2. And then it's the same thing. The derivative of this is 2x over x squared plus 1. We already did that derivative earlier, but there it is, okay? So I did the derivative. Oh, that was so much easier than having to do the quotient rule and doing the chain rule inside here where we bring down the 2 and do that and whatever, right? So a lot easier. If we want to clean this up a little bit, this 2 and this half are going to cancel. And this 2 I can put in the numerator. And so y prime over y is 2 over x minus 2 minus x over x squared plus 1. And at this point, mathematicians generally don't like to leave a math problem to be done. We're going to find a common denominator and multiply this by x minus 2 over x minus 2 and multiply this by x squared plus 1 over x squared plus 1. And I have y prime over y equals 2x squared plus 2 minus x squared minus, this is like a minus 2, so it's going to be plus 2x all over the product of x squared plus 1 and x minus 2. Okay, so hopefully we're good with that. We get some things that are going to simplify here. This whole thing becomes x squared plus 2x plus 2 is this and this are like terms, right? And then y, if we go back and we think about what y is the same as this thing, right? So I have x minus 2 squared over x squared plus 1 to the 1/2. And when I divide by a fraction, I'm going to flip it over and I'm going to multiply by the reciprocal. So I'm going to be multiplying by I'm dividing this. This is really, I'm multiplying both sides by the denominator to get rid of it, right? So I'm going to multiply this side by x minus 2 squared over x squared plus 1 to the 1/2. because this is like, if this were like y prime over 4, I'd multiply 4 on both sides. This is essentially what I did. Okay, so you can think of it as multiplying by this, half, these cancel, and I'm left with y prime. So I'm going to clean this up a little bit more and notice that one of these and this one combine, and then this is like this to the first power and this to the half power. So when I'm all done, I have y prime equals, in the numerator, x squared plus 2x plus 2 didn't change. I have this extra x minus 2. And then in the denominator, this 1 and another half is going to give me x squared plus 1 to the 3 halves. Which, if you like, this wasn't that bad. It wasn't hard. A little bit of steps, but not hard compared to trying to do the product or the quotient rule and the chain rule. I didn't have to really mess with that too much. So there's my derivative. That's why logarithmic differentiation is a little bit easier if we first take the log of both sides and then split up that big compound term into as many little terms as possible. That's animated here for you kids with better handwriting. So if you want to look at that, all the things that we just did continue. And anyway, all right. So sometimes you'll see an absolute value around the u. And that's just to make sure it fits in the domain, because we can't put negatives in there because they're not part of the domain of x. So when I'm doing a problem like here, we're going to say, all right, sometimes cosine's negative. But if we use the absolute value, we're saying only for cosine values that would be positive. Or if we get a negative, let's make it positive. And we're going to take the derivative of this. And our derivative is still in the form of u prime over u, where this time u equals cosine of x. So du is, what's the derivative of cosine? Negative sine, right? So I'm going to rewrite this, or this is u prime, right? So f prime of x is negative sine of x over cosine of x. And then we can look at that sine over cosine. This is the same as like negative tangent of x. All right. So those are the notes. Now you're going to go through and you're going to do the 12 problems I have picked out in WebAssign. It's really helpful if you haven't watched the first part of this video to go back and watch the log rules if you don't remember them. Because much like in our logarithmic differentiation here, back in this step, it's easier if we break this up instead of trying to do the quotient rule into pieces, right? And some of those rules to break them up are in the other video. So